So I'm going to demonstrate about predictive parser. Uh, predictive parser. Before we get into it, we must know what it is. So recursive descendant is a top-down parsing technique that construct a parse tree from the top. So top-down parse tree has recursive descendant, backtracking and non-backtracking. In non-backtracking parser, we have something called predictive parser. So this parsing technique reversely parses the input to make a parse tree which may or may not require backtracking. Now, before getting into the program, this will be the input symbol. So I have to create a parsing table first. The parsing table will include some non-terminals and the input symbols. And these are the transitions from the non-terminal and the input symbols. Now, when I'm parsing, suppose this is my input and I have to check if this string is accepted or not. So, if this is my input, I'll start from the very first non-terminal, that is E. So, $E input will be in stack. The input will be my given string and the output. So, it will first check the top of the stack with the given input. So, E and ID, and it will compare it with the parsing table. So E and ID have the transition E gives T E dash. So I write in the output as E gives T E dash. Now after that I have to write this E gives T E dash, the production only, in the opposite form. So here I write E gives, so instead of E I'll write E dash of T, that is the opposite of T E dash. Now again I have to check T and ID. So T and ID in the transition table corresponds to the transition T gives FT dash. So I'll write T give FT dash. So instead of T, I'll write FT dash in opposite direction. So it is T dash of F. So this goes on till the end. Now here one status will come that will show it is the stack symbol is T dash and it is dollar. So in T dash and dollar it is T dash gives epsilon. So I write T dash gives epsilon here, and epsilon means null value. So I'll just remove T from here. So the remaining value is T dash and dollar. Now E dash and dollar corresponds to E dash and dollar correspond to E gives epsilon. So at last I'll have only dollar at the top present at the top of the stack as well as the input symbol. So once this two is matched, I can say that the predictive parsing has been completed and the string is accepted by this parser. So for the code, I have this packages of buffer reader, input stream reader, array list, scanner, etc. So in the class array stack, I have a character array, then top and size, and in a function called array stack, I have given the size as 20. I have initialized basically, and top is initialized to -1. So here I have the basic push and pop functions. In the display function, I'll just display the array of I. So here comes the main function. So I have a string array, a two-dimensional array called transition, that is used for storing the transitions, that is basically will generate your transition table. And I have initialized everything. Now I'll ask the user to enter the number of terminals, non-terminals, starting non-terminal symbol. After that, all the terminals will be entered simultaneously and non-terminals will be entered simultaneously. And instead of epsilon value, I am giving the @ symbol. Now after everything is done, I'll ask the user to enter the values in transition table. So once the values are entered, now I have to read the input. So once I give the input, I have to make sure that I end my input with $# symbol. Now first the index is initialized to 0. After that the output will be as stack input and output. So if I'll first check if the character at index not equal to hash, then I'll just display it. Now whatever is the character input character, I'll store it in character of 3, and the index 1 is initialized to alphabet index of character 1. Now if transition table has a null symbol, then it will prompt me that the given string is not accepted. Otherwise I'll split whatever is there in the transition symbol, I'll split it from this arrow symbol and write it in the reverse direction. So for example, as I told you earlier, this will be splitted and written in the reverse direction. So once it is done, so I'll check if popping of the symbol is possible or not. So if character ch is equal to character of 3, that is the stack symbol, top of the stack and the input symbol matches, then I have to pop. Otherwise I have to push the symbol. So once it is done and the input character at index -1, so the after everything is completed, at the end, if the input symbol is equal to $, it means the parsing is completed, and I'll ask the user whether the parsing has been completed or not. So for the output, this will be the output. So first I'll enter everything. This will be my transition table, and I'll end my input with this character. So this is my input, and the output is like stack input and output. So E gives TA. So it will compare it with the parsing table and generate the symbols like this. So at the end, once both the stack and input symbol have $, it will say that the parsing is completed successfully. This is how the predictive analysis is done. So once at the end I have this $ symbol at both stack and the input, I can say that the given input is accepted by using this predictive parser table. So this is how it is done. Thanks for watching.